It's me, Josh, again. Thought I'd do a video on my steam condensate trap that I made. I think it was a couple months ago. Here it is. This this is all aluminum. It was made out of one solid chunk. Besides this exhaust, this is a 3-inch piece of brass pipe. Just bought it at the store. Here's the whole inlet for the steam condensate. Here's the exhaust. Here's the inlet or the body. There's the inside. Sorry for the glare. There's the bottom. That hole there is for the machining process of on the lathe. This is the top. This is the stack. It's about 1 inch tall. Here's the back. This is press fit into this top piece. In total, I probably had doing 3 or 4 hours a day, maybe 2 weeks, maybe 3 weeks. It's hard to keep track. All this is a slip fit for this. Keeps it from coming off. Originally I was gonna do threads here, but actually no, I wasn't. I was gonna do threads on this part right here, but my grandpa talked me into just doing a press fit. Press fit is easier, and plus there's no chance of corroding because this thing will corrode over time. This is a piece of 1/8 inch pipe, brass pipe. These are 20. I have it's 27 threads per inch. Right there on the end. I basically, when I was done with all this, I polished both these two pieces and this brass pipe up. It's kind of tricky to make. These are the plans. I will post a video a little bit clearer at the end of this video. Yeah. I made it. I drew. This is the original set of plans. It's worn out because this is my copy that I did when I machined it. You can see it didn't fare quite well, and plus a lot of the dimensions are wrong. So when I was done, I dimensioned this with a caliper and other tools. So this copy is right for this. Basically doing this hole in the the drill was the last step I did on this. The first step was making the top. I first drilled this in there so it'd be easier with this not on. I turned this. This is a 55-degree angle. I didn't make this chamfer. I just resurfaced it, and I found it's 55 degrees. This thing isn't straight on. That's due because I had to change it out quite a few times on the chuck. Plus I wasn't really sure what I had to do because this is basically my first prototype. Basically what I did was, with this not on, I drilled this hole for the press fit, first I bored that all the way down to in this piece, so it would be less machining, and plus I could use a boring bar. I also bored this out and turned this down to diameter. That's one of my cats. He likes to sit on the back of my chair. Don't mind him. Then after I bored this down, I parted this off, like that. Then I turned this down. Wait, no, was working on the top. After I got this press fit, the press fit diameters, the outside of this is 90.93 of an inch. Would be 9. Whatever. It's a let's see. Where did I put that? Maybe it's on the old one. It's like a 5/10,000th press fit. I don't even think it was even that. It was actually 6/1000th press fit actually. 45-degree chamfer on the inside here and here, and then a 45-degree chamfer on this side. And it's a 16-degree chamfer on the inside to help with the press fit. Aluminum's very soft. It was very easy to press fit this into here. Yeah. It's about an inch tall from here. About 17 thousandths of an inch depth right here from the edge of this. I did an experiment with this before I kind of was kicked out of the machine shop. I ran it on my steam engine to see how much condensate would hold. About half a boiler. It was already up to the edge of this thread right here, so I bored it deeper and works just fine. I don't really have time, or it's too late to do a steam engine run. This is more informational video. The diameter, outside diameter of this is 1.607 of an inch. This is 1/4 inch right here. The total thickness of this is 0.489 of an inch. Inside diameter is 3/4 of an inch. Outside diameter is 0.958 of an inch. The depth of this chamfer is 1/4 of an inch. Same on this. I think this one's a little bit deeper. This diameter right here is 1.603, and this one's 0.1607. The total diameter of outside here is 1.880. Outside diameter is the same. The depth, according to the drill, is 2.614 inches. Sorry, I'm looking down at the drawing. The total length is 3¼ inches. It's pretty good height. I based all this off a Jensen model 2025. It's a electrical heated reversing double acting steam engine. I will put a link in the description of where I got it. where I got was ministeam.com. I had very good success getting it. I also bought a big thing of their cylinder oil. I use it in the steam cylinder. I would recommend using this steam oil that comes with it for all the joints and stuff like that. Inside diameter is 1.320. I was drilling, and I think the largest drill I used was 1 1/4 inch, or actually no, I think it was a 1 1/8. Actually no, it was 1 1/4 inch drill I used in here, and to drill it to depth. There's a little bit of a step in there. That's alright. It's fine. Doesn't affect anything. Just adds a little bit more capacity. I bored it out to the 1.302. Basically, right here is the edge of my finger, and it goes like that. My finger is that long. So, the center of it is 0.460 of an inch from the top of this. It could be a little bit different for your model, for your steam engine or whatever. I use 1/8 inch pipe thread because that's what I had. I had this, a 1/8 inch T nipple, and a crusty sponge holding this up against, and this thing would fall over, and I would have steam all over the place and condensate. Because the Model 25 throws out a lot of condensate. A lot of the Model steam engines do. It's all dependent on the relatively humidity of the air. Let's see. This is 0.13. Yeah, that's kind of irrelevant. It's used to hold on a live center on a lathe. I actually had to use a really large engine lathe to make this because the tailstock was too. I used a smaller one, and the tailstock wouldn't reach, so I would have clearance to go from here all the way down to finish it. It's a really snug fit. If I twist it to a point, this will actually jam. It's a really tight fit. Everything is a very tight fit. Polish all the outsides, the brass. You could even use some high temperature silicone tubing and a 1/8 inch nipple and run a flexible line to your engine. This will still trap it. This height is based off my steam engine and my desk, because I have a little bit of a step on my desk. It's a 1/8 it's a 1/8 inch pipe thread, 3 inches long. Drill letter Y to allow the threads to be put in and allow for some of the pipe inside to stick in to allow the steam condensate to fall down there. Let's see. It's a 1/4 inch from the bottom of this. The depth of the deepest part of the hole is a 1/4 inch from here. It's 0.047 depth from edge of this to the wall. It works really well. To buy this chunk of aluminum would probably be cheap. This pipe was probably only $2-3. This one probably took me a good 25, maybe 30 hours, maybe 40 hours to make this. I'm really happy. Only regret I have is that this pipe is crooked. If this thing sits flat, you can't really see. You can see this it tilts this way a little bit. So I have to tilt this back a ways, due to inaccuracies on where I drilled it and whatnot. So I take the steel plate I found at my work. It was from the old oven. I stick it under, like that. It brings it back. It doesn't come off. It collects quite a bit. I could probably with this run 2 runs of. I almost could run a full boiler with this. This probably would only cost you, I don't know, maybe $30, maybe $20 in materials, and then it's all machining. This is not, I had basically, I made this because of purpose, and I had free time at the end of my, class, because I finished up earlier than most people. I was only taking 3 classes, but that's besides the point. Yeah, so I did this because I had free time. I needed it to a point where my old setup was frustrating. Yeah, so this works very well. The only thing I would change is to make this more up, like that, so steam would actually go in without me having to tilt this thing back. Stable. I'd try and make sure that this is concentric, like where there's barely any lip on this, because if you look down here, not so much, there's a little bit of a lip here, not so much on this side, but on this side it's real pronounced. You actually can kind of see it. There's basically when this is on there, there's that large of a gap. I used all the edges on this just so come in. This mark was a drill mark, which happens. I'm very pleased with this. I will put a link in the description where I got the steam engine, and I'll put a picture at the end of this. It'll hopefully get it up by the end of the night. Until next time, happy steaming. Hi YouTube, it's me again. I forgot one note. Before I put the after pictures, I'll put some before pictures on what the stock looked like. I got it for free. It was scrap, so it didn't cost anything, so it was just my time machining it. Thanks again, and happy steaming.